Hello, and thank you for coming to my presentation entitled Unconfounding Unconformities, Geology of the Southwest Highland Mountains, Montana. I'm Chance Ronimus, and I'll be describing the results of a USGS EdMap project focusing on 1 to 24,000 scale geologic mapping of the eastern Melrose and western Wickiup Creek 7.5-minute quadrangles located in southwest Montana. I'll briefly describe the regional setting of the Highland Mountains, which are located here. They're located in a zone of tectonic overlap between several regionally significant provinces, including this province of basement uplift in southwest Montana, the severe fold thrust belt shown in light blue here, and the batholithic province, locally including the Boulder batholith, present with one of its satellite lobes present in the northern map area, the Moose Creek Pluton shown here. I'll give a general description of some structures and stratigraphy in the map area, then talk a bit more specifically about one specific problem. So present in the map area are sedimentary rocks from Mesoproterozoic through Paleozoic, as well as tertiary cover. Additionally, metamorphic basement is present, as well as Cretaceous and younger igneous intrusions. Major structures in the map area broadly fall into 5 main structural domains. The first comprise west dipping faults in the Paleozoic section here. The second are steep basement-rooted structures, the South and North Rochester faults. The third is the north-dipping, east-west striking Camp Creek fault. The fourth are normal faults that bound the Divide Valley. And the fifth is what I'll be addressing here, the enigmatic contact between the Cambrian Flathead sandstone and metamorphic basement rock. Regionally, this contact, known as the Great Unconformity, is an erosional feature along which much geologic time is missing from the stratigraphic record. However, in the Highland Mountains, this Great Unconformity exhibits signs of potentially also being a sheared contact or a fault. Specifically, farther away from this contact, as it's exposed in Camp Creek here, the basement consists of a variably folded myelinite. However, closer to the contact, we see a retrogradationally metamorphosed chlorite schist. Additionally, this contact is marked in places by a quartz vein breccia, as well as cut by smaller structures shown here. Microstructures are likewise supportive of some kind of brittle deformation, with fracturing of opaque minerals visible here and infilling by chlorite clay gouge. You can see a fractured quartz in this photo from sample HL24. Both of these samples were collected in the south map area around here. We conducted apatite helium low temperature thermochronology to explore the thermal history experienced by the rocks in the map area, as well as the potential differential thermal history across this contact. In particular, if this contact was a major extensional feature, we would predict to see cooling in the footwall or the metamorphic basement prior to later erosional cooling in the hanging wall associated with exhumation along the structure. However, we can see at right that these two samples collected proximally above and below the Great Unconformity instead yield overlapping good fit envelopes, or envelopes defining possible time temperature histories found by this modeling program, indicating that faulting along this structure was likely not the dominant control on the time temperature history recorded by the apatite helium system. In summary, it's likely that there's some amount of shear across the Great Unconformity contact in the Highlands. The kinematics of this shear and its magnitude are a bit more enigmatic and may require further investigation.